Today's lesson is on writing scientific notation. First, we're going to look at writing large numbers in scientific notation. So our first number is 50,000. We want to put our decimal to the right of the first non-zero digit. So if we look at our number, 5 would be the first non-zero digit, and we want our decimal to go to the right of that, so we would go behind it. So our decimal is going to go right behind the 5, right here. So we're just going to have 5.0000. We do not need to include those zeros when we write our scientific notation. So we'll have 5 times 10, and now we need to figure out our exponent. We want to figure out how many places we had to move our decimal to put it right behind this 5. It originally started at the end of the number, so we moved it 1, 2, 3, 4. Since our number we started with was greater than 1, our exponent is going to be positive. So our exponent would be just 4. So we have 5 times 10 to the 4th power. For number 2, we have 1,650,000,000. We want our decimal to go to the right of the first non-zero digit. The 1 is the first non-zero digit, and if we put our decimal to the right of it, we put it right behind it. So we're going to have 1.65000000. Again, I do not need to include all those zeros. So I have just 1.65, or 1 65 hundredths. Then I'll have times 10, and now I need to figure out my exponent. So I need to figure out how many places I moved my decimal over. So I started at the end, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved it over 9 places, and since my original number is greater than 1, my exponent is going to be positive. So I have 1 65 hundredths times 10 to the 9th power. Now we're going to look at writing small numbers in scientific notation. So for number 3, I first want to put my decimal to the right of the first non-zero digit. So if I notice here I have all these zeros, and now I find my 2. That's my first non-zero digit. It'll go to the right of that digit, so it means it's going to go behind it. So I'll have 2.68. I do not need to put all those zeros that are in front of that 2. And then I have times 10, and I need to figure out how many places I moved my decimal. My decimal in the problem is in between those first 2 zeros, so I moved it over 1, 2, 3, 4, 5, 6. So I'm going to have 6, and since my original number that I started with is less than 1, my exponent is going to be negative. So I have 2 68 hundredths times 10 to the negative 6th power. Now for number 4, I want my decimal to be to the right of the first non-zero digit. So if I start at the beginning and I move over, my first non-zero digit is this 5. I want my decimal to the right of it, so that means my decimal is going to be right behind it. So I have 5.06. This 0 does need to be included in my answer because it's in between 2 numbers that are not 0. But all the zeros in front of the 5 do not have to be included. So I have 5.06, or 5 6 hundredths, times 10, and now I need to figure out what my decimal, or what my exponent is going to be. So I'm going to move my decimal over 1, 2, 3, 4. So I have my exponent of 4, and since my original number I started with is less than 1, my exponent is going to be negative. So I have 5 6 hundredths times 10 to the negative 4th power. Now we're going to multiply numbers in scientific notation. So for number 5, I have the quantity 2 5/10 times 10 to the 8th power times the quantity 2 times 10 cubed. I can use the commutative property to help me rearrange the numbers in this problem. So I can go ahead and write 2 and 5/10 times 2 times 10 to the 8th power times 10 cubed. Now I can use the associative property to show me which ones I'm going to multiply together. So I can go ahead and multiply the first two, and I can multiply then the last two. 2 and 5/10 times 2 is 5. And then I'd have 5 times 10 to the 8th power times 10 cubed. We can use our product of powers property, which tells us that if we have the same base, we can add our exponents. So we're going to have our base of 10, and when we add our exponents, we have 8 plus 3, which is 11. So my answer is 5 times 10 to the 11th power. Now for number 6, we have the quantity 3 times 10 to the negative 5th power times the quantity 5 times 10 to the negative 2nd power. So I'm going to go and use the commutative property, and I'm going to have 3 times 5 times 10 to the negative 5th power times 10 to the negative 2nd power. Now my associative property can help me see what I'm going to multiply together. And now 3 times 5 is 15. And then I have times, my base is going to be 10, and my product of powers property says that I'm going to add my exponents. So negative 5 plus negative 2 would be negative 7. If I look at the answer I have, 15 times 10 to the negative 7th power, I will notice that that's not in scientific notation, because my factor in the front here should be at least 1, but less than 10, and 15 is greater than 10. So I need to write 15 in scientific notation. So I need to put my decimal to the right of the first non-zero digit, which would be right after that 1. So I have 1.5, or 1 and 5/10. And then that would be times 10, and I would have moved my decimal over 1 place, so it would be times 10 to the 1st power. My 1 is going to be positive because my original number was greater than 1. And now I still have then times 10 to the negative 7th power. I can now combine 10 to the 1st power times 10 to the negative 7th power because I have the same base. So I'm going to still have 1 and 5/10, and then I have times 10, and my product of powers property says I would do 1 plus negative 7, which is negative 6. So my answer is 1 and 5/10 times 10 to the negative 6th power.